only takes up 2% of a human's weight, but due to its role in complex processes, it consumes 20% of the body's energy at rest. Large blood vessels in the brain are responsible for the brain's metabolic processes. Traveling up the left and right sides of the neck are the carotid arteries. The internal arteries branch into anterior and middle cerebral arteries, which are responsible for ensuring that 2/3 of the cerebral hemisphere is supplied with blood. Vertebral arteries travel along the spinal column and base of the skull and are responsible for supplying the posterior cerebral arteries with blood, which they pass on to the rest of the cortex. Vertebral arteries then fuse into the basilar arteries. They feed the posterior cerebral arteries as well as deliver blood to the hindbrain. These three arteries then connect at the Circle of Willis, which is located at the base of the brain. This mechanism provides an alternate route for blood in the event of a stroke or other damage. The endothelial cells that form the walls of capillaries have extremely tight junctions. This is the basis of the blood-brain barrier. It makes it more challenging for large molecules and other unwanted substances from the blood to enter the brain and cause infection. There are many brain imaging techniques that reveal the structure and function of the living human brain. Angiography is a technique where cerebral blood vessels are filled with a radiopaque dye. Then X-rays are used to provide detailed views of these parts of the brain. It is used to diagnose vascular diseases. Computerized axial tomography, commonly known as CAT or CT, is an X-ray that is moved in an arc around the head. Detectors simultaneously move around the other side to measure the level of absorption. This measurement is proportional to the tissue density, which can be used to build a map of the brain. Magnetic resonance imaging, or MRI, is a magnet lines up the protons located within nuclei, which are then knocked over by a pulse of radio waves. When this happens, the protons emit radio waves as they return to their original configuration. This information is used to create a cross-sectional map. Diffusion tensor imaging, or DTI, is a technique that utilizes the property of fractional anisotropy, meaning water molecules move down a gradient within the axon, and the measuring of this provides images of axonal fiber pathways. This is also called fiber tracking. A positron emission tomography, or PET, shows the brain's activity. Radioactive chemicals are injected into the bloodstream and mapped by radiation detectors to show where these chemicals go, signifying activity during a specific task. Functional MRI, or fMRI, produces images with high spatial resolution and moderate temporal resolution, which detects small changes in brain metabolism by measuring oxygen levels in a given region of the brain through examining blood flow or hemoglobin levels. These are called BOLD signals, which stands for blood oxygen level dependent signals. Optical imaging is the use of near-infrared light to be transmitted through the scalp to detect reflection, which represents electrical signals and blood flow. Transcranial magnetic stimulation, TMS, aids researchers in stimulating specific regions of the brain without needing a hole in the scalp or skull. This process of stimulating specific areas of the brain is called electromagnetic induction. Magnetoencephalography, or MEG, use squids to map activity during cognitive processing in real time. Squids are ultra-sensitive detectors that recognize magnetic fields created by activity in local circuits. It is useful when studying rapid changes in brain activity. There are sophisticated imaging techniques that are powerful tools requiring cautious interpretation. This technology has helped research structural and functional properties of a living brain, but with this comes procedural and experimental limitations. For example, an fMRI can be very detailed but sacrifices efficiency. In addition, computer algorithms are considerable for debate and controversy.